Episode 322, Pear Blossom and the 6th IPCC report. This is the Change Underground. I'm your host, John. Decarbonise the air, recarbonise the soil. The 6th IPCC report, link in the show notes, was released last Monday, a day after I'd published the last episode, of course. So I've had a week to get my head around it and hopefully distill it down to a more manageable yet still accurate summary. Also today I was setting up the chook run for winter, expanding the run area and calling in the semi-feral chooklings who are between 10 and 16 weeks old, when I noticed, and remember we're at the end of the second month of autumn in the southern hemisphere, I noticed one of the pear trees had a spray of open blossom. What I first noticed was the sound of bees, then the flowers, but what's going on? So I've gone deeply into the 6th IPCC report, and here's my summary, in the same neutral tone as it was written, I hope, if I can keep the disquiet out of my voice. Buckle up. Current status and trends. Global surface temperatures have increased by 1.09 degrees C, higher in 2011 to 2020 than they were in 1850 to 1900. With larger increases over land, nearly 1.6 degrees, than those over the ocean, 0.9. The likely range of human-caused global surface temperature increase between 1850 to 1900 compared to 2010 to 2019 is somewhere between 0.8 and 1.3, with the best estimate being 1.07. Well-mixed greenhouse gases contributed a warming of 1 degree to 2 degrees. And other human drivers, principally aerosols, contributed a cooling of 0 to minus 0.8 degrees C. Natural, that is solar and volcanic drivers, change global surface temperatures between minus 0.1 to plus 0.1, an internal variability from minus 0.2 to plus 0.2. So they basically wipe each other out. The observed increases in well-mixed greenhouse gas concentrations since around 1750 are unequivocally caused by greenhouse gas emissions from human activities over this period. The cumulative effect of net CO2 emissions from 1850 to 2019 were about 2,400 gigatons of CO2, of which more than half, 58%, occurred between 1850 and 1989. So from 1990 to 2019 produced 42% of greenhouse gases that are in the atmosphere. So global net anthropogenic greenhouse gas emissions have been estimated to be about 59,000 gigatons in 2019, about 12% higher than in 2010 and 54% higher than in 1990. With the largest share of gross greenhouse gas emissions occurring in CO2 from fossil fuel, combustion and industrial processes, followed by methane, whereas the highest relative growth occurred in fluorinated gases, starting from low levels in 1990. Average annual greenhouse gas emissions 2010 to 2019 were higher than in any previous decade on record, while the rate of growth between 2010 and 2019, 1.3% per year, was lower than between 2000 and 2009, 2.1%. So there's some good news. In 2019, approximately 79% of global greenhouse gas emissions came from the sectors of energy, industry, transport and buildings combined, and 22% from agriculture, forestry and other land use. Emission reductions in CO2 due to improvements in energy efficiency have been less than emission increases from rising global activity levels in industry, energy, supply, transport, agriculture and buildings. Greenhouse gas emissions are continuing to rise, with average annual greenhouse gas emissions in the past decade higher than in any previous decade on record. Immediate and ambitious actions to reduce greenhouse gas emissions and limit impacts of climate change are needed. Observed changes and trends. Human influence has warmed the atmosphere, ocean and land, and this has resulted in a rise in the global mean sea level of 20 centimetres between 1901 and 2018, with the average rate of sea level rise increasing significantly since 1971. The increasing frequency of extreme weather events such as heat waves, heavy precipitation, rain, droughts and tropical cyclones can be attributed to human influence since at least 1950. Climate change has caused substantial damages, reduced food security and affected water security, hindering efforts to meet UN Sustainable Development Goals. Furthermore, climate change has caused widespread adverse impacts and related losses and damages to nature and people, which are unequally distributed across systems, regions and sectors. Approximately 3.5 billion people are highly vulnerable to climate change. Increasing weather and climate extreme events have exposed millions of people to acute food insecurity and reduced water security. Human mortality from floods, droughts and storms was 15 times higher in highly vulnerable regions compared to regions with very low vulnerability between 2010 and 2020. Although overall agricultural productivity has increased, climate change has slowed this growth over the past 50 years globally, with related negative impacts mainly in mid and low altitude regions, but some positive impacts in higher latitude regions. Ocean warming and ocean acidification have adversely affected food production from fisheries and shellfish aquaculture in some oceanic regions. Roughly half of the world's population currently experiences severe water scarcity for at least part of the year due to a combination of climactic and non-climactic drivers. Podcast footnote: non-climactic drivers are things like wars and repressive governments. End footnote. Climate change has caused adverse impacts on human health, such as increasing the incidence of vector-borne diseases, i.e. malaria, via mosquitoes being the vector, and climate-related foodborne and waterborne diseases. Mental health challenges are associated with increasing temperatures, trauma from extreme events, and loss of livelihood and culture. Climate and weather extremes are increasingly driving displacement, that is, people are moving, particularly in Africa, Asia, North America and Central and South America, with small island states in the Caribbean and South Pacific being disproportionately affected relative to their small population sizes. Now for some goodish news. Progress and adaptation. Progress has been made in adapting to climate change across all sectors and regions of the world. Growing public and political awareness of climate impacts and risks has led to at least 170 countries and many cities including adaptation in their climate policies and planning processes. This is a positive development as it indicates that governments and communities are taking action to mitigate and adapt to the impacts of climate change. The effectiveness of adaptation in reducing climate risks has been documented for specific context, sectors and regions. For example, cultivar improvement, on-farm water management and storage, soil moisture conservation, irrigation, agroforestry, and community-based adaptation have been effective in reducing the impact of climate change on agriculture. Sustainable land management approaches, uses of agroecological principles and practices, and other approaches that work with natural processes have been effective. Ecosystem-based adaptation approaches such as urban greening, restoration of wetlands and upstream forest ecosystems has been effective in reducing flood risks and urban heat. Combination of non-structural measures like early warning systems and structural measures like levees have reduced the loss of lives in case of inland flooding. However, most observed adaptation responses are fragmented, incremental, sector-specific, and unequally distributed across regions. Despite progress, adaptation gaps exist across sectors and regions and will continue to grow under current levels of implementation, with the largest adaptation gaps among lower income groups. There is also increased evidence of maladaptation in various sectors and regions, which especially affects marginalised and vulnerable groups adversely. There are soft limits to adaptation, which are currently being experienced by small-scale farmers and households along some low-lying coastal areas, resulting from financial, governance, institutional and policy constraints. Some tropical, coastal, polar and mountain ecosystems have reached hard adaptation limits, indicating that even with effective adaptation, loss and damages cannot be entirely prevented. The key barriers to adaptation include limited resources, lack of private sector and citizen engagement, insufficient mobilisation of finance, including for research, low climate literacy, lack of political commitment, limited research and low uptake of adaptation science, and above all, a low sense of urgency. There are widening disparities between the estimated costs of adaptation and the finance allocated for it. Although global tracked climate finance has shown an upward trend since the previous assessment report, current global financial flows for adaptation, including from public and private finance sources, are insufficient and constrain implementation of adaptation options, especially in developing countries. Adverse climate effects can reduce the availability of financial resources by incurring loss and damages and through impeding national economic growth, thereby further increasing financial constraints for adaptation, particularly for developing and least developed countries. On the upside, though, let's look at it this way. Progress has been made in adapting to climate change. There are still significant challenges that need to be addressed to reduce the impact of climate change on vulnerable communities and ecosystems. It is essential that governments, communities and the private sector work together to overcome the barriers to adaptation and increase investment in adaptation options to ensure that we can effectively manage the risks associated with climate change. Progress, gaps and challenges. Policies and laws addressing mitigation have consistently expanded since the last report, which is a positive development. Many regulatory and economic instruments have been successfully deployed, resulting in several gigatons of avoided global emissions. However, there are still gaps between projected emissions from implemented policies and those from nationally determined contributions, which make it likely that warming will exceed 1.5 degrees C during the 21st century and make it harder to limit warming below 2 degrees C. Several mitigation options are technically viable and becoming increasingly cost-effective, such as solar energy, wind energy, electrification of urban systems, urban green infrastructure, energy efficiency, demand-side management, improved forest and crop grassland management, and reduce food waste and loss. The cost of solar energy, wind energy, and lithium-ion batteries have decreased significantly, and their deployment has increased, varying widely across regions. However, projected emissions far outpace climate goals set by governments. So progress has been made in mitigating global warming, but there are still significant gaps and challenges that need to be addressed. Immediate action is required to limit warming to 1.5 to 2 degrees C, and a strengthening of policies is required to bridge the implementation gap and achieve the goals set by the Paris Agreement. Looking forward. Future climate change. If greenhouse gas emissions continue, global warming will increase in the near future, with the best estimate of reaching 1.5 degrees C even under very low greenhouse gas emission scenarios. This would intensify multiple and concurrent hazards, and changes in extremes will continue to become larger. However, deep, rapid and sustained reductions in greenhouse gas emissions can lead to a discernible slowdown in global warming within around 2 decades, and also lead to discernible changes in atmospheric composition within a few years. Under different greenhouse gas emission scenarios, discernible differences in trends of global surface temperature will begin to emerge from natural variability within around 20 years. Moreover, targeted reductions of air pollutant emissions lead to more rapid improvements in air quality within years compared to reductions in greenhouse gas emissions only. In the long term, further improvements are projected in scenarios that combine efforts to reduce air pollutants as well as greenhouse gases. Continued emissions will further affect all major climate system components, leading to projected changes such as intensified global water systems, very wet and very dry weather, and climate events and seasons, and reduced extents and/or volumes of almost all glaciers in the world. Natural land and ocean carbon sinks are projected to take up decreasing proportion of these emissions, and the Arctic will be practically ice-free in September at least once before mid-century under all scenarios considered. To mitigate these risks, the importance of deep reductions in greenhouse gas emissions in all sectors and regions, along with the implementation of measures to reduce air pollutant emissions, is essential. This includes policies such as carbon pricing, fossil fuel subsidy reform, regulations and investment in low-carbon technologies. Moreover, the need for international cooperation, especially in the transfer of low-carbon technologies, capacity building and financial support to developing countries is critical. These long-term responses would require transformative changes in the economy, society and governance systems. So not all bad. Mitigation pathways. Global efforts to limit warming to 1.5 degrees C with no or limited overshoot, and those that limit only to 2 degrees, require immediate and rapid greenhouse gas emissions reductions in all sectors this decade. All global modelled pathways that fit these criteria require either net zero carbon emissions by the early 2050s or around the 2070s if we're going to stick under 2. These global model pathways include significant reductions in CO2 and non-CO2 greenhouse gas emissions. Specifically, global methane emissions are expected to be reduced by 34% by 2030 relative to the 2019 in pathways that limit warming to 1.5 degrees C. However, some hard-to-abate residual greenhouse gas emissions remain, which are emitted from sources like agriculture, aviation, shipping and industrial processes. These emissions would need to be counterbalanced by deploying carbon dioxide removal methods to achieve net zero CO2 or greenhouse gas emissions. So to reach net zero CO2 or net zero greenhouse gas emissions, probably go for the latter I would suggest, significant reductions in gross emissions of CO2 are needed, as well as substantial reduction in non-CO2 greenhouse gas emissions. While there are some hard-to-abate residual emissions that remain, the deployment of carbon dioxide removal methods, planting trees, could help to achieve net zero emissions. Additionally, transitioning from fossil fuels without carbon capture is also included in global modelling mitigation pathways that still reach net zero. So there's urgency, but there are benefits to near-term action as well. So climate change is a major threat to the well-being of humans and the planet. It is urgent we take integrated climate action to secure a sustainable future for all, which involves adapting to the changes already happening and reducing greenhouse gas emissions to limit future changes. The choices and actions implemented in the current decade will have long-lasting impacts for thousands of years. Climate-resilient development, which integrates adaptation and mitigation, is necessary and enabled by increasing international cooperation, inclusive governance and coordinated policies. Continued emissions will lead to irreversible changes on a millennial timescale, threatening ecosystems, biodiversity and human well-being. The benefits of taking near-term action are significant. Deep, rapid and sustained mitigation and accelerated implementation of adaptation actions in this decade would reduce projected losses and damages for humans and ecosystems and deliver many co-benefits such as improved health, air and water quality and energy access. The benefits of taking action outweigh the costs, and the longer emission reductions are delayed, the fewer effective adaptation options there will be. The window is closing, people. Governments, civil society and the private sector play a crucial role in enabling and accelerating the shift towards sustainability and climate-resilient development. This includes making inclusive development choices that prioritise risk reduction, equity and justice, and integrating decision-making processes, finance and actions across government levels, sectors and timeframes. Enabling conditions for climate-resilient development vary by national, regional and local circumstances and include political commitment, coordinated policies, social and international cooperation, ecosystem stewardship, knowledge diversity, technological innovation and improved access to adequate financial resources, especially for vulnerable regions, sectors and communities. So in summary of the summary, things are crook. We could do other things to make them less crook, and if we don't, things will turn crooker quickly. And still, that out-of-season pear blossom was quite beautiful. The Change Underground Academy No-Dig Gardening course is still available, link in the show notes. Decarbonise the air, recarbonise the soil. Thank you all for listening to this long one. I'll be back next week. This has been a JM Podcasting Services production. Link in the show notes.